Hello, my name is Bryce Odom, and this is Lab 3, a black hole. And part 1, we had to calculate the mass of the black hole, and these were our initial conditions that were given: the mass of the star, delta T, and then the only force acting on the star was F grav from the black hole. These are some important formulas to remember. Is the momentum formula, which is momentum equals mass times velocity, and from Newton's second law, we can see that the change in momentum is equal to F net, and an F net has a parallel and a perpendicular component, and then you can separate the momentum vector into its magnitude and direction, and then you do the product rule and you get all this. And then this is for part 2 of the lab. This is really important because to remember that when we're updating the velocity and the position for non-constant forces like gravity, which depend on position, we use v final instead of an average, and then you can rearrange the formula for calculating the force of gravity on an object, and we could rearrange it to solve for the mass of the black hole, which is that mass of the black hole. Givens right here, and then this is our calculation loop. We had to compute the initial and final momentum vectors using the mass times the velocity. And then we had to calculate the change in momentum. And then because change in F net is equal to change in momentum, we saved that variable. And then we calculated the parallel component of the change in momentum and then the perpendicular. And then we used that all to calculate the mass of the black hole, which was all of this code right here is this formula right here, but it's just in code. It's the same thing. And so that would give us a mass each time the loop iterated, because this was in a while loop. And so what I did was I created a variable called total mass to calculate after each iteration. It added the mass calculated in that iteration, and then the next one, and the next one. And so we got a big, huge number. And then we had a counter variable that I also created. So it would calculate how many iterations we did. And that would give us and then so what you did was you take that total mass variable after all the iterations are run, and then how many iterations we did, and we get an average mass of the black hole, which was calculated to be 1.5415 times 10 to the 34th, and it also calculated the magnitude of F net parallel, and F net perp. And then we use that and then this is the parallel component, the perpendicular component, and then this is the parallel component, and this is F net, just to see it as the code was running. And the video, and as you can see, this is the planet orbiting the black hole, and you see how when it's close, it's like the F net is super strong, and then there's basically no parallel component, only the perpendicular component. And then when you get around here, the F net becomes super small because both of the other components are really small. And then in part 2, we were assuming that we were launching from the planet in a spaceship, and we were trying to get as close as we could to the black hole without hitting it, and we had to determine what the initial velocity would need to be in order to not hit the planet. And we used the mass of the black hole from the previous part that we calculated. And here's our code. This is where I put the mass of the black hole, and then these are our givens, our constants. And so the way we did that was we had to calculate net force of the planet, net force of the spaceship, and we also had to calculate planet's velocity and its position, the ship's velocity and its position, so that way we could see if our ship was able to hit it, and not get hit. And the way we did that was by trial and error, and I found that to get close but not hit the black hole or the planet, you needed to have this x component and this y component, and there was no z component because it's two-dimensional, meters per second. And it was a negative x, so we wanted to go this way, but we also wanted to go this way, so that way we could still get pulled in by the black hole, but not too much. And then if we wanted to orbit it, it was a very long video for this one. I'll show you in a minute. But this purple is the orbit of the ship, and then this is the planet to keep from getting hit, but also to kind of orbit it and let the gravitational force from the black hole pull us in. And some possible sources of error was that we calculated an average for the black hole. The mass of the black hole was an average calculation, so it could technically be wrong. And then if we use it in part 2 of the code right here, then that could mean that all of this other stuff afterwards is also wrong. The only difference between FNet parallel and FNet and DP, the change in momentum, is that's the only difference. Is we calculated this one, but we deduced this one.